Hello everyone, welcome to my channel on data analytics. I am your host, Professor Rage Udaykiran. In this video, we are going to talk about polymorphism. The concept of polymorphism in object-oriented programming is divided into two parts. In this video, we are going to cover the first part. The outline of the presentation is as follows. First, we look at how a compiler moves in a single Java class. Next, we check and learn how a compiler moves in a Java class if it has an inheritance with another Java class. Next, we talk about polymorphism. Then we look at dynamic binding, which is the important property of a polymorphism. Next, we look at implicit and explicit casting. This concept of casting, as widely studied previously for variables. Now we look at how the casting happens for objects. So this is the total overline of today's presentation. Now let us see the first topic, which is how a compiler moves in a single Java program. So we assume that a program contains only one class. So for ease of explanation, I have converted a Java box into black boxes. As you can see here, I have a public class Minato. So this class I have represented with blue color. So on the right side, the blue box represents the whole class. In this class, using the orange color, I have written the global variables. These variables in the abstract form shown as the golden or orange colored rectangle. Next, we have created the constructor for this class and written in green color. So using the green color on the right side, we have created a box. In a class, there can be multiple constructors. So we have written constructor 1, constructor 2, so on up to constructor n. Next, we have multiple methods in a class file. So here I have written a class file in pink color. These methods, which are not constructors, are represented with a yellow rectangle. We can have any number of methods. So I have written the value k here. Okay. So this is the abstract representation of a class. So please keep in mind a class will have global variables, constructors and methods. Methods and constructors can have their own local variables, but they are not of point to us at this point of time. So please pause this video and try to grasp how a class can be represented in the abstract form. This abstract form is very useful in understanding how the compiler moves. Now, let us see how a Java compiler moves. The Java compiler first visits the class. As you can see here, Java program is first visiting the Minato class. The same is shown on the right side. Now once it enters into the class, next it looks at the global variables. Okay, it tries to initialize these global variables. Once these global variables are initialized, then it enters into a constructor. If there are multiple constructors, then it, depending upon the input parameters, the compiler will choose an appropriate constructor at the runtime and enters into the constructor. Here, the compiler will perform all the steps mentioned in that constructor and exits if the constructor is not calling any method. Once Java compiler comes out of a constructor, an object is created and the object creation process will end. It means you cannot call the constructor once again. An object has been created. So this is how the compiler moves and creates object. Once you create the object using the object dot method, you can access any method with ease. These methods can be called any number of times in any order. Okay? Whereas the constructors can be called only once and they have to be the beginning. Now let us see how a compiler moves if there is inheritance between them. This is the classic example we use in the class for discussing on inheritance. Okay, we have superclass and subclass. The subclass can behave as a superclass for another subclass. So we have Minato, who is the father of Naruto, and Naruto, who is the father of Minato. Given these three classes, we want to establish inheritance and see how the compiler moves. For brevity purpose, we confine our discussion only to superclass and subclass. Okay? We will not discuss about the another level because the philosophy remains the same. Before going into the study of compiler movement, can anyone answer the question? What is the advantage of inheritance? Please pause this video and try to answer the question. What is the advantage of inheritance? The answer is we can reuse the variables and methods of a parent class. We don't have to redefine them. We can reuse. That is the advantage of inheritance. Now let us see how this inheritance, especially EZA, works. So in the abstract representation, if we have a class Naruto that extends Minato class, what happens is we will have another class which becomes a subclass and there will be a pointer pointing to the superclass. So this you can think of as an abstract representation of a superclass. So this will easily help you in seeing how the compiler moves. If we have another extents for Minato, then we will have another extents from Minato to here. We know in Java, object is the superclass for every class. So we can also say that this superclass Minato extends object class. Now let us see how the compiler moves. So here we are putting the Java compiler. Step 1. What happens is when we execute the class Naruto, the Java compiler first enters into the Naruto class. Okay, so you can see the same thing here. Now, for Naruto class, we are using the keyword extends Minato. So, instead of compiler going directly into the Naruto class, first it enters into the parent class or superclass Minato. So, once the compiler comes to the Naruto class, without going inside, you can see that it is jumped into the superclass Minato. Once it enters into the Minato class, it will first create the global variables and then enters into one of the constructors, completes the constructor's thing and comes out. So this complex behavior, since it is difficult for me to show, I have simply kept it as a box. So the compiler comes to Naruto, goes to Minato class, whatever the task it has to perform in the Minato, they will be completed, and then the compiler enters into the Naruto class. Okay, you can see here, the compiler enters into the subclass, creates the global variables, then enters into the constructors, complete the steps that are mentioned in the constructor, and then it comes out. Now, let us see how the things happen using the program. So, step 1, we are at the Naruto. Next, what we do? Shall we go down or we go to Minato class? Please think. Okay, the Naruto enters into Minato, and from here the compiler goes to Minato class, creates all the global variables, and then enters into the Minato constructor. Once these steps are completed, then it enters into the Naruto class, creates global variables, and enters into the constructor, performs whatever steps are written in the constructor, and then exits. So this is how the compiler moves. Now the question is, why do we have to learn the compiler movement? Understanding the compiler movement is crucial because the next topic, to understand what is polymorphism, this compiler movement is very crucial. If we do not understand this compiler movement, and then when we try to create multiple objects from parent to child and child to parent in the concept of polymorphism, the understanding becomes difficult. So it is important. In this context, I have first covered the compiler movement. Now let us look at the polymorphism. If you have observed the inheritance, we can see that a superclass is basically useless. Okay, the reason is you can use the subclass to create variables and methods. So one can think that a superclass looks like a scapegoat, but unfortunately that is not the case. Superclass is bestowed with a powerful concept called polymorphism. So what is the polymorphism? The superclass can create the objects for any subclass. This is the important property of a superclass. Superclass can behave like an object for any of its subclasses. Don't worry, let us try to see how a superclass can be used to initialize a subclass. Let us look at this program. In this program, we have a superclass person. This class is being extended to another class student. So I am using the green color to represent the superclass, the blue color to represent the subclass. I am using the light blue color to represent another class which is I am calling polymorphism demo. In this class, we are going to create the objects and let us see how the polymorphism functions. So if we look at the main function, we are creating the object yes for the student. You can see here. This is normal, okay? Using the class, you can create the object. Similarly, observe that since person is a superclass of a student, using the person class, you can create a object of student class. So in this case, what happens is you are creating an object P which is accessing, which is going to work same as the object yes. So once you are going to print the functions s dot introduction and p dot introduction, we will get same answer. So let us see how it happens step by step. Watch carefully. The parent class, I am representing it with the green color. So in this green color, there are global variables, constructors and methods. Okay, we have global variables, constructor methods. I am not adding them here for simplicity purpose. Similarly, for the subclass student, I am going to use the violet color and it also has global variables, constructor and methods. So this is how the person and the student are extended. Now, what happens? Let us see if we have a Java compiler that will first enter into this demo class. Since this demo class has public static void main function, it enters into this function. Next, it will read the first line, student yes equivalent to new student. So once it reads this line, since this is a student, what happens is this will first visit the student. Okay. Because of the extension, it will not go inside. It will go into the parent class, performs all the steps inside the parent class, and then comes to the child class. And it performs the necessary steps in the child class and comes out. So once this has been done, what happens is in the RAM we will create an object yes whose name is Saito and ID is S1153333. So this object we have created after completion. After this line, we come to the parent person. The parent object P is assigned with yes. Since they are not P and S are objects and not primitive data types, what happens is we create the object P, but instead of initializing it with different values, we will use the memory pointer pointing to yes, which means yes and P we are same objects, are identical. Now, once we go to the next line, that is yes dot introduction. Okay, here, since yes is a student, we come here, okay, goes into goes into I am student, prints this text and comes here. Next, P dot introduction. Since P is same as yes, what happens is from here this will go to introduction and then the corresponding lines will be printed. So this is how it happens. Notice here the parent was able to create an object of the child. So this is the advantage of polymorphism. Now let us see what is dynamic binding. So to understand dynamic binding, let us create one more example. In this example, our superclass person remains the same. The subclass student, which extends the person, also remains the same. But the demo class that we are writing is different. Let us try to understand. So in this demo class, we are creating a student object and we are passing it to the method m. If you look at the method m, its input is a person. So the input to the method m is an object whose type is person. So that is the requirement. Next, if we look at the second line in the main, here we are creating the object for the person and we are passing it here. Okay. So this is the program. If you observe the method m, you can notice that this method m accepts only person objects. Now, if we watch the main function, okay, we are trying to pass a student object into the function m, can we pass an object of a class which does not belong to the same class? Can we do it? Please think in your brain whether these lines will create any bugs or any errors in your program, because this is a student object, this is a person object. They are both different ones, right? So if I am passing it, will it create errors or not? Now, if your answer is no, then it is correct, because a child can act as a parent object. In the previous slides, we have seen that using extends, child inherits the variables and methods of a superclass. So, a child can behave like a parent object. So, if there is a method whose input requires a parent object, any child can simply go into that function with ease. This is called dynamic binding. So when you do dynamic binding, it is a very complex process. So dynamic binding, okay, do not happen during the compilation. Instead, dynamic binding happens at the runtime. One can see that dynamic binding looks so interesting to do, but we suggest not to use dynamic binding extensively in your code, because if the errors happen during the runtime, it is very difficult to know the cause of that error. So try to use dynamic binding only when necessary. If possible, avoid dynamic binding by carefully designing your classes. Dynamic binding is crucial as if the communication needs to be happen independently. So now let us see how the dynamic binding happens. You can see I have written the class, superclass in the green color, the child class in violet color, and the demo class in blue color. So how do we represent the superclass and subclass? Using this diagram. Now let us see what happens. Okay, I am going to use black color to represent the movement of the compiler. So the compiler comes to the class polymorphism demo 2. Since there is no extents to this class, the compiler enters into the main function. In this main function, the compiler visits the line, first line, where we are creating a new student object who with the input parameters Saito and ID as S11533. So after reading this line, student is violet color. So you first enter into this class. Because of the extents, what happens is you will enter into the parent class, that is person, complete all the steps mentioned in the parent class, come out of the parent class and enter into the subclass. Once you complete the steps in the student subclass. In the RAM, we will create the object for the student with the name Saito and ID as S115333. Now observe what has happened. Once this step is done, the compiler, I am using violet color, it enters into the function M. Okay. Now the object that is within this method is student. Okay. So we are taking the object student and we are coming here person. Since person is a superclass of the student, at the runtime, the Java allows it to enter into this M function without any problem. Okay. So it enters into the M function, goes to the line system.println where we are calling x.introduction. So notice that even though we are using x as an object to the person, when you say x.introduction, the compiler will not go to the superclass. Instead, the compiler smartly recognizes the object and goes into the subclass introduction, and then it prints the text. But while printing, what we are doing, I am student, we are using the super function and asking the compiler to visit the parent. So after reading that line, the compiler goes to the superclass introduction, returns my name is Saito, and then prints the ID. So this happens. So from the child class, if you want to call the function of the parent, you simply say super.introduction. Then the compiler will go to the corresponding function in the superclass, completes it and come back. So once this is done, the object is created and the text has printed. Now you see the compiler now became black because this step has finished. Now using black color we are going to create the person here. So when we are creating the person here, what happens? Because we are creating for object, we simply go to the class person. Since person does not extend any other class, we simply enter into the function, create global variables, enter into its constructor, okay, and then we come out. Once we come out, we will create a new object P. This object we will now send it to M. Now the object inside is a person object. Since it is a person object, this y, okay, the compiler allows it to enter into person x m method. Then after coming inside the m function, here there is x dot introduction. So since the object is a person, the compiler will not go down because it's a person object. So the compiler will send, okay, to person's introduction method, completes the steps and comes up. So you can see that depending upon the object that is being entered into the M function, the compiler is deciding whether to call a subclass or call a parent class. This dynamic behavior is called dynamic binding. Okay, you can see same code, but you depending upon the object we are calling respective introduction functions. That concept is called dynamic binding. Hope you understood how the dynamic binding works. Because of this complex behavior, if your program incurs any error, debugging becomes very hard to tackle. That is why try to minimize the usage of dynamic binding. The dynamic binding will behave little bit slightly when you are calling static methods or static variables, because I have told you clearly static means there can only be one class or one variable. So always keep in mind that, okay, if a variable or a function has the word static or final, the behavior is slightly different. So to understand, always keep this point in mind. Static variables and methods behave differently. Let us see with an example of how it happens. So we have a superclass, we have a child class. Observe that this main function is not a separate class. Instead, it is written as a part of child class. Please do not get confused with the previous demos where we had the main function class file. Here we are having main function in the child class itself. When we execute the child class, what happens is the compiler first enters into the main and then creates the object of parent. So here what happens? It will go to parent. Since there are no global variables or no constructors, okay, it simply comes down, creates the object O1 and then visits the second line. In the second line, you can see that for parent object O2, we are creating the object of the child. So what happens is, because we are creating the object for child here, the compiler comes down. Child. Okay. From child, because of extents, it goes to parent. Okay. So it goes back to the parent. Does nothing because there are no global variables and constructors. So simply completes and enters into the child class. In the child class, there are no global variables or constructor. So simply a dummy child object O2 is created and the next line is visited. This line says child O3 whose object is an instance of the child. So again, this will also perform the same. Okay. So we are going to the child. Okay. We are going to the child. Enter into the parent. Perform all the necessary steps in the parent. Come back. Since there are nothing left, okay, you simply create the object of the parent and we come here. I hope what we have done here you all understood. Now I will erase the lines, okay, for brevity so that I can explain the next lines. So I have erased all of the lines. Now let us see what we are actually doing in this line. This line we are creating the object O1 whose parent is also a new parent. Okay, they belong to same class. Okay, the left hand side and the right hand side, they belong to same class. So let us use the green color and create an object. Okay, so we have an object. I am going to create two. Okay, you can think this is left hand side. Okay, and this is right hand side. Now, once this object O1 has been created, we are visiting the object line 2. Here, the parent is creating the instance of a child class. Okay, so it is not a pure one. So what we are trying to do here is we are creating a parent. Using the parent class, we are creating the child. Okay, so this is the object O2. Next, this one is pure. So let us create for child. Now let us come to the next line, parent dot my static method. Okay, so here we do not have anything. So this line will go to the parent, enters into the my static method, prints a, okay, and comes out. Here we are saying child dot my static method. So if you are calling child, we don't, because it we are already inside it. Okay, so we go into static method, print C, and then we come. Please note that we are not going up here because we are not creating any object. We are simply calling the method that exists in this class. Now let us see what happens with O1. Okay, so for brevity, let me clear all the ink. So once we come to the object O1, okay, so object O1 is pure parent. So we enter here. So object 1. So we enter into parent, enter into my static method, print A, come out. Now it is object 1 dot my instance method. So you go into the parent, use my instance method, print B, and then come to the object 2. Please remember that object 2 is a mixed type. Okay, so what happens here is when I say my object 2 dot static, see we have two methods here and here. Okay, so it will not enter into the child. Instead, it will go to the static method, prints A, and then comes. Okay. Why it is not entering into the static method? I have told you there will only be one static method. So the parent method will be created. Okay, we will not have access to it. Once this method is there, the compiler will go. It will not go there. That is the point for static. Now, if you come to instance, my instance method, observe that here we will not go to parent because this is many copies are allowed. So here we go to instance method. For static, we went to the parent because this is the main one. So we come here, print D and come to OC. O3 is there. O3 static method is basically here. So it prints C, then comes to the instance method. At the instance method, it will again go to instance method, prints D. Okay. Next, once the output D is printed, it will come here. Okay. Now you see my static method. Please keep in mind this rule. Static can call only static. If your method is static, then you can only call static methods. Because my static method is a static method, the compiler will enter inside. Okay. Once it reaches here, there is no static word here. Means you are allowing duplicates. So it becomes very difficult for the compiler to understand this non-static method because this is itself is a static method. So here you will get the compilation error and the program will quit. This is how the polymorphism works. If you are not familiar with this topic, please go back, okay, to the beginning of this slide and try to see what is actually happening. We have now come to the end of the lecture and we are talking about the last topic called casting. In casting, there are two types, implicit casting and explicit casting. Why do we need these two types of casting? Let us try to understand now. Please look at this tree structure. Okay. So in this class diagram, okay, what do we observe? We observe two important points. The first one is every child has only one parent, but parents can have many children. Okay, so is this information is crucial for implicit and explicit casting. Okay? Let us see how it happens. Let us take our classic example Minato, Naruto, and Boruto. Okay? Now, Naruto and Boruto can say, I am like my father, and Boruto can even say, I am like my grandfather. Because Naruto inherits the properties from Minato and Boruto inherits the properties from Naruto. So when we convert this behavior into an object oriented programming, we can say like this. A Minato object can have a new Naruto object. Okay, because Naruto's behavior is somewhat influenced like with Minato. Similarly, Naruto object can have Boruto's instance. Minato being the grandfather of Boruto, using Minato you can create a Boruto class object as well. Okay. Now we will not say that I am like my son. That is not possible. Only the son will be inheriting the properties of the parent. Okay. So we will not say that Naruto nor object can inherit the class Minato. This is not possible. Okay. Only a parent can act as the object of its subclass that we have discussed in the polymorphism nature. Okay, a child cannot create the object of a parent. Having said that, now let us look at implicit casting. Okay, in this case, Minato object is created. For this object, we are creating a new Naruto object and casting it into the Minato object in this line. Okay, so what we are doing is we are creating the object Naruto and then we are casting it to the Minato. We are creating the object and we are doing the casting. Okay, same thing we can say here. Okay, Naruto also. We are creating an object Boruto and casting it to Naruto. Similarly, the last line, we are creating the instance Boruto. Okay, so from down to up, we can cast because they are parent, grandparent, so on, so forth. In this case, you see, since a child can have only one father, okay, Java compiler can easily traverse and do the casting. No need to worry. Okay, because a child can have only one parent. So it is easy to traversal and identify the right parent. That's the reason why we don't need to worry about mentioning the parent casting. This is called implicit casting. Now, let us look at the scenario. Here, we have created the Boruto object and casted onto the Naruto. This is fine. Now, from Naruto, okay, I want to convert back to Boruto. Okay, so the basic way we can do is we can create an class Boruto object and assign it to Naruto. Very simple. But what happens is when we write like this, the compiler in the reverse it will come down. Okay, but here it will get confused where to go because a parent can have many children. The compiler gets confused to which child it has to move. Okay, if you simply mention like this, the compiler gets confused. I have two children here. Which one I have to go? It cannot understand. Okay, so to eliminate this confusion, we have to say, okay, here, go to board. Here we have to mention board. Okay, so let us see how we do it. So in explicit casting, if we have Naruto, a parent having a casting of the child to get the child back, you should not write like this. Instead, you have to mention the compiler that from Naruto go to board. Sorry, there is a typo. Here it will be board. Okay, sorry, this is a typo. This is board. So this is how we do the explicit casting. Okay, from bottom to top, no need to mention anything. But if you are going from top to bottom, you have to explicitly mention. Now, let us look at the important option. When we are doing this implicit and explicit casting, many problems or runtime errors occur due to dynamic binding. To solve that problem, we have instance operator. This operator is same as who are my command in the operating systems like Linux. Okay? Because if an object is taking the many shapes or names, it becomes important to know which class a particular object belongs to. To identify it, we use instance. Okay. Let us look at the previous code. Here we have, okay, so we have a parent class called person, and then we have a child called student. Okay. Now a person object P is having a object of the student. Okay. Now if I want to say P dot get ID, I will get the compilation error because the person class do not have the function get ID. This is in the student. Okay, this function is in student class. So to eliminate these kind of runtime errors, we always use the instance. So when we create the instance, okay, we check if the instance of P is student or not. If it is a instance of a student, then you call the function getID. Otherwise, you simply say print the name of the student. Okay, because that variable is there in both person and student. Okay, so to check what kind of instance it is, we often use this operator instance of. Next, most important one is when you are doing this type casting, okay, we should know the order, how this order will be understood by the compiler. So let us look at this part. So when you are when a compiler sees a line, okay, there is a precedence order. So keep in mind that casting is lower than the dot. Okay, so the dot is given more important than the casting operator. So please do not write like this. Okay, if you do like this, okay, if you put student in the bracket, okay, casting, and if you say PID, first P.PID will be executed, and then whatever value you get, it will be converted into the student object. This is wrong because if P is not from the student class, this function will create the runtime error. So to eliminate those errors, first what you have to do is using the braces. First convert the object into a particular class here. Okay, using the braces, you first convert the entire object into the student class. Once the object is converted into the student class, use the function of the student class for execution. Okay, this way you have to do. If you write like this, you may get runtime errors. So please keep that in mind. Always first do the typecasting of objects and then call the functions or the variable names. Okay, that's all. Thank you very much for listening to the video. If you have any doubts, feel free to put message in the comments below. Thank you very much.